Okay, so in this video, we're going to take a step further in the transcended idea. Yeah. So, to those who are not aware of what we mean by the transcended idea, is this. Um, you know, when when you are taught biology, either at junior level or secondary level, when you reach that part where being taught about uh, tropic responses in plants. So you're talking about chemotropism, geotropism, phototropism, hydrotropism, yeah, and yeah, among others. You know, we're talking about, for example, talking about chemotropism, just talking about the response of a plant to chemicals that are around. Phototropism, just simply talking about the response of a plant to light as a stimulus. Hydrotropism, just talking about the response to a moist environment, of which in that case is brought about with the presence of water. All right. Then talking about geotropism, it is said to be the positive or negative response of a plant to the force of gravity as a stimulus. Meaning, when they say as that elongation of the roots going down into the soil, they say that is perceived by the plant in respect to the force of gravity, meaning gravity is the one that is the driving force for the roots to go down into the soil. They say towards the center of gravity. But yeah, for us, we think otherwise. Looking at the relationship, looking at the, let me say, the insight of the way gravity works, when you look at it from the physics point of view, I believe that is something that was not supposed to be included. Yeah, that's not something that was supposed to be included. It's okay if we say geotropism, but not in respect to gravity, because gravity works depending on the type of material that you're using, depending on the fluid that you're using. If you're talking about an open space, which is gas, or you're talking about a fluid like water, so it's more like gravity remains the same. And for example, if I drop this marker that I'm using, if it experiences a free fall, it's being acted upon by nothing else but gravity. Okay, now I find that when you go in different different mediums, you find the gravity will remain the same, the mass of that object will still remain the same, but you find that the speed the speed at which that object is going to be moving through that medium is going to be altered, because like it's going to be altered by the properties of that particular medium. All right, so when just looking at the background of this geotropism issue or gravitropism, we say like Charles Darwin's interest in plants resulted in the publication of several books in those days. So the second half of Mr. Charles Darwin's scientific activity, which was like from 1850 to 1882, as the record says, it was like dominated by botany, which is the study of plants. So one of his last books was titled the Power of Movement in Plants. It's a record of numerous experiments which Charles Darwin performed together with his son Francis Darwin. Okay, so the early experiments in the 18s show that Charles Darwin was the first one to document both positive and negative geotropism in plants. The work of Mr. Darwin led to the discovery of auxin, okay, the plant hormone, and the relationship to and this relationship to cell growth in plants. Okay, so when talking about the elongation of the roots and the shoots in plant development, yeah, they say it's credited to gravity, and you find that they say the shoot grows against gravity, meaning it shows negative geotropism. Then the roots, they say it grows towards, like, it is being acted upon by gravity. They say it shows positive geotropism. So you find that in the early days of the year 2020, um, we thought of working on something that would help pupils understand better in schools on certain topics. So in this case, we're talking about the responses in plants. And what we did, it's more like we get all the tropic responses, the main ones, and we apply them on a certain experiment, so that when a pupil sees such, it will be quite easier for them to understand that particular topic, not just seated in class and just getting those notes into their heads, this and that. But when they see it from the practical point of view, it becomes quite easy to understand. Yeah, such that they can even do it on their own free time. So what we did was we got a plant and had to put it in a certain container. Okay, so it's more like we say this was the container that we used, right? Then we had to put the seed there. It germinated because it is soil. So it germinated this seed. Let's say this seed germinated, and as time went by, after germination, it didn't go, because like it was more like we say this here we had the stand. Okay, then at this point we had a source of light. So in this case we're using bulbs that emit heat, because what we needed is not just sunlight, not just light, but we needed the favorable temperature for this plant to germinate. Of course, a moist environment as well as the presence of oxygen. So this plant, this seed germinated. So it went in this direction for a short distance. Then it started to make a turn, because this was an open space. So as much as light was coming from this direction, you find that we had light in several directions coming to this plant. So it made the turn to go up like that. So you find that after some time, it didn't maintain the 90 degrees angle that it had. It started to open up again, because you find that we had to inhibit the incoming of light from the other direction, just focusing the light on this direction. So from this, we were able to understand phototropism, hydrotropism, the presence of a moist environment. What else they say? By then, we were also able to say geotropism issue, this and that. But as time went by, we started becoming skeptical to say, when you observe the plant start to make a turn again to go in that direction and started to increase the 90 degrees angle, we realized to say these processes don't just happen. There's a reason why they happen. There's a reason why the plant shows positive phototropism, simply because it wants to expose the leaves to sunlight so as for photosynthesis to take place. So we realized to say, okay, now we asked ourselves, we found out to say this is the reason why photosynthesis takes place. What about hydrotropism? We gave ourselves a reason. Geotropism. And like from the fingertips, you can say, okay, geotropism is because it wants to drive the roots into the soil so that they get the necessities of plant growth. But when you apply physics, it doesn't just add up. All right, it doesn't just bring things together. But when again, it's very important again to realize that a plant is a living organism. If you look at the phenomenon of how about like on how it responds to chemicals, water as well as light, it's so overwhelming, I tell you. And it's very important to realize to say this is a living organism. Okay, so you find that for us, of course, in the beginning, just started was just a skeptical idea, this and that. But the reasons that would give ourselves was, of course, the roots just go into the soil to explore the nutrients of the soil. So now the question was, how do we show that really the roots go in the soil to explore the necessities of plant growth and development? Okay, so when you look at the root system, this is just a rough diagram. You can see it from the screen there, the proper one. So I find that here we have let me say we have root hairs. Okay, here we have, let's say this is the root cap. Okay, then on the middle here, my most area of attention is say elongation. Okay, so when you look at the root system, as the root develops, like the first root to develop, it says it's called the radicle or something. Yeah, so as the roots develop, the region of the region of elongation, like the epicomeristem behind the root cap somewhere here produces new root cells that elongate, and you find that the zone of elongation is where the newly formed cells increase in length, thereby lengthening the roots. So you find that on this part, new cells are formed. and the root starts to develop in length here, thereby increasing the length of this root. And you find that as you increase the as the length of this root is increased, you are increasing the surface area for that particular root to have root hairs, which are going to help in the uptake of water as well as other nutrients as the plant grows and develops. All right, so you find that to us, we believe to say this root has a sensing mechanism on the root cap, because that's why you find cells such as cells that are called statocytes, and they contain statolis, which are statolis, this word, oh, stato, okay, statolis. So you find that these are like starch filled organelles, and to say in the current study, these are believed to be the ones that help in the perception of gravity, but we say no, to that one. All right, so we say this sensing mechanism is more like this is spearheading everything. It senses to say, okay, now which part of the environment, let's say for example this root has, this is a soil, then you say this part and this part, and continuously going down. You say here we put something poisonous, here we maintain good soil, and here good soil. It's obvious to say this root won't bend to go in that direction. It will continue going in this direction or make a turn to that direction, because it wants to like absorb those nutrients as well as the other necessities of plant growth and development. So here's what we did. We got a container, a small bottle, mineral water bottle. Okay, let me just highlight it with the marker so that it will be visible enough. Okay. So right there, we planted the seed, a maize seed at that point. So you find to say here where it's indicated using black dots, and here red, we say at this point, let me say region A here, we say this is the fertile environment. Then B is infertile, meaning let's just use the word poisonous. So in this case, what we did here, this is just a mixture of Cl, powdered Cl, as well as chlorine. Here we also have other materials like washing soap, this and that. Then on this point, what we have is good soil. We got soil from the garden and combined it with some chicken manure, so that at least it becomes as fertile as it should be. So upon planting a seed here, what we were asking ourselves is this: are the roots of this maize seed going to continue going deep down in this environment where it is poisonous, or they're going to stuck around here? They're just going to stick around, hang around, absorb as much as possible, as well as make a turn to go to this direction. So the thing is, if they could have continued, or if they will continue going down in this environment, it will mean to say the issue of gravity is correct. But if they make a turn to go the other side, it will mean to say the transcended idea theory about, like this argument against geotropism being defined as in respect to gravity is correct, because it could have meant to say these roots are just sensing to say, okay, now which environment is best for absorption of water as well as all the necessities of plant growth and development. So now, here's the thing. We're not going to review what happened, but this video is just there to help us explain how the experimental setup was just put, and it's up to you to say, okay, now we start predicting to say, now where are the roots going to go? Are they going to make a turn to go to that side, or are they going to continue going down and respect gravity as it is known at the moment? Yeah, so the follow-up video is the practical thing of this. It was done, yeah, and yeah. So from this moment, this is all from this that's all from this video. Yeah, and in the next video, of course, we are going to show the recorded video of the actual plant itself and dismantle it and see how the roots went and how they develop, how did they continue going in this direction and the other direction. So one emphasis again, these processes that are mentioned, they are not just processes that happen from nowhere. There is a reason why they happen. There is a reason why a plant should bend towards the light. And here's a question: do you believe, to say, for example, you get a small flower, okay, let's say that it has leaves all over, it has leaves, then you provide light on a certain day, of course it will bend towards light. Then you get the same plant again, detach the leaves, then you provide light that side. Do you think this is going to bend towards the light? That's a question that we need to ask ourselves. So now, from that point of view, we are able to understand, to say these processes, there is a reason why they happen. It's not because of gravity. And again, when bringing the issue of gravity, it's very important that we remember to say, physics speaks a different language about the work of gravity. All right, in like its relationship with its relationship with the motion of any object in different mediums. Yeah, so that's all from this video. Thank you.